Okay. Howdy. Today we will be presenting a short demo on how to set up DNP3 outstation points in the WSCC 9 bus system, and then how the data that's collected from those DNP3 objects is then pushed into the database. And then once the data is in the database, we'll be able to show how an SQL injection attack can be performed in real time. So for the WSCC 9 bus system, this bus system, as mentioned earlier, is characterized by 3 generators. And the system is also divided into 2 main areas, Area 2 and Area 1. Area 2 is on the left side of the screen, and it includes generator 2. And Area 1 is on the right side of the screen, and it includes generator 3. And bus 1 is the slack bus in this system. So to set up the DNP3 outstation, we go into the model explorer, and we can see here that we have one outstation defined. Once we click on show dialog, we are able to see the DNP3 objects that were specified to be collected for this case. So in our case, we are collecting the megawatt for both generators 3 and 2. We are also collecting the bus frequencies of buses 3 and 2. And then we're collecting the megawatt flow in branches 5 to 4 and 7 to 8, both the megawatt 2 and the megawatt front. And the reason we are doing that is because branches 5 to 4 in this system and branches 7 to 8 are the tie lines that separate the 2 areas. And we are using all these values in order to calculate the ACE and the AGC set point as shown earlier in this presentation. So once we have saved the DNP3 objects, we will go to the Dynamic Studio simulator, and then we will go to double check that all the information has been passed on. We will go into case information onto DNP3 outstations, and we can see that all 8 points were passed, and we can also click on show dialog and on all points, and we can also see that all these points and all these values have been passed on to Dynamic Studio. And one thing worth mentioning is that all these values are the initial values, and these are the values, especially the branch megawatt flow values. They are the ones that are going to be used to calculate the initial tie flow values that will be used to calculate the ACE. So once we have verified that, we'll just double check on the simulation options. So we will have a continuous simulation, and this is important because we will be performing the attack and collecting the data into the database via real time. So we start the server and then start simulation. And then as you can see, the simulation is running right now. The frequency is at nominal frequency of 60 Hertz because we haven't changed any load values in the system. And all these values that are being collected are the initial values that are used for the initial tie flows. So we would then go on to the terminal window, and then we would go into the virtual machine. So the idea is that we are gonna now be collecting the data from that simulation, and then also pushing it into the database. So once we start running that, we can see that the data is being collected in real time, where the first 2 values are the generation values for generators 2 and 3. The second 2 values are the ACE values, and then the last 2 values are the AGC set points. Since, as I specified, we are currently on the initial values, the ACE values are set at 0. But if we were to go back and, for example, reduce the load on bus 6 from 90 to 86 megawatts, we can quickly see that the frequency is increasing, and that is actually reflected here where the ACE is no longer 0, and the AGC set points are also changed accordingly. And then another thing that we can try to see is that if we were to, for example, change the load back to 90, the frequency will start decreasing, and the ACE value will start decreasing and going back to 0 as the system restores nominal frequency. So with that being said, now this data that's being collected in real time is going to be pushed into the SQL database. And to start with that, we will be going into the database right here.
Yeah, thank you, Leen. My name is Namrata, and I'll be navigating through the SQL injection attack. So to perform the attack, we have already the SQL server up and running here. So basically, we have installed the SQL server in the virtual machine. And now, as we can see, the SQL server is up and running. It is active. So what exactly the SQL injection attack? So this attack, basically like the cyber attack, injects the malicious SQL code into an application and allowing the attacker to view, modify, or delete the database, which is very critical attack. And to perform this, we have used the Postman API. So I'll be navigating to Yeah, so here we have the Postman. And before going on the Postman, I would like to explain what exactly the Postman API is. So this API enables us to create and send any API request. And also we can identify or we can define the endpoint. And then we can retrieve the data from any data sources. Or also we can test our API. So this is the login page which we have built. And as you can see here, we have given our VM IP address, which is 10.229.147.16 and the port number. And this is our endpoint. So when I mention the endpoint, this is the login web page. And the same thing which I have called here, as you can see in the request. So I have mentioned the get request. We have all the different HTTP requests. So here I have mentioned the get request. And then as we can see, I have called the API endpoint here, Python login, and also the virtual machine IP and the port address. And then what I can do is like the basic SQL injection attack, which is I'm trying the value 1 equal to 1, which is always true, right? And in this one, what I have done, I have called the another endpoint, which is the table update. This is basically my DB, the database. And here what I can do is we see in the previous one, the value was something different, but now I'll try to change the generator value. So we have different table and I'll try to change one of the values. So let me change here to and send this request. So as we can see the 200 okay status code, that means the request has been sent successfully, and then we can go back to our SQL server and check whether we have modified or changed the value or not.
So going back to the SQL server, which will show right here to show that the attack has happened. So here, this shows the database, and as we can see, we have been able to successfully pass on the SQL injection attack to modify the generator to values to 555. And since the simulation is running in real time, after the time has passed to when we passed on this command, the code goes on and continues to collect the generator to values. So with that being said, this concludes our short demo.